Okay, now let's take a look at how the computations are happening behind the scene. Okay, so here the what you are seeing is the 0.15, 0.25, 0.30, 0.2. These are all the weights. These weights are randomly assigned to each synapse. What is synapse? You know, the connecting line between the input layer and the hidden layer. So every neuron, every neuron is connected to every other neuron in the subsequent layer. So here, in this case, we have input layer. In the hidden layer, we have two neurons. In the input layer, we have two neurons, and the output layer, we have only one neuron. So the output layer is the one, emitting whether the given person is eligible for loan or not. Okay, the output node is the one tells us whether, or the output node is the one produces the predicted class level along with the probability. Okay, we can say instead of class we can see probability also. So here this is the age of the person, and then income of the person. Here these two values are normalized. You know what is normalization? So standard, if we did the feature scaling, with that we are, we got these two values. You just think that way. Each neuron is assigned to one attribute in the table column. This is age and this is income, something like that. Here, the 0.15, 0.25, as I said, these are the weights randomly assigned to each the line, okay, connecting line. So now we will take a look at how this works. As I explained you in the yesterday's session, in the case of hidden layer, what happens is, one second. Yeah, each neuron in the hidden layer, I just go back here. This is what I'm taking. Each neuron in the hidden layer, it takes the two inputs. So it takes the two input values plus the bias and compute its output as this one. So here Z is equivalent to W1 into H plus, let's say to make it simple, W3 into income. Okay, and then the value whatever we are getting it, that one will get assigned to Z, and that Z will be passed as an argument to the f of Z, and then here it will compute the sigmoid value, which is nothing but you will get the probability value. If you remember that image here, right? So that is what is happening here. So each neuron, it takes the input values. In this case, we have two input values plus the bias. Even for the bias, we have some weight here, plus the bias, and it computes its output as this one. Z is equal to X into W. So this is X into W1 plus W3, W3 into 0.5 plus 0.10 into the 0.2 plus W4 into 0.30. Okay, and that is what is happening. And we call this as a net H1 for the sake of our understanding. And this is out H1. Okay, this is hidden layer. Hidden layer, the naming convention, we use it net H1. This is your out H1. Okay, and okay, this is out O1. Okay, so fine. So now if you look at this here, the equation here, so I'm going to talk in detail about the Z. Okay, the Z is your W1 into I1 plus W2 into I2. So net H1 here is 0.15 into 0.5 plus 0.2 into 0.2. Okay, this is the one. Okay, 0.2 into, sorry, 0.2 into 0.1. Okay, so this one. Okay, 0.5, 0.15 into 0.5 plus 0.2 into 0.01, 0.1 plus 3.5 into 1. Okay, so this is the value computed first. So if you do the math here, you get something like this. You will get finally 0.3775. And if you apply the activation function for this value, 1 to 1 plus e to the power this value. And then next one is the W3. So the next one is W3 into the I1 plus W4 into I2. This one. First, it did for this one. The next one is this. And in this case, net H2. This is your net H2. Net H2. And this is your out H2. In this case, what happens is 0.25 into zero point 0.5 plus zero point 0.3 into zero point 0.1 plus 0.35 into 1. So each layer, the bias will be added. So that this is the bias. Okay. This is kind of your intercept in your linear regression. That is what I discussed yesterday. And the next one is for this one, the net H2 value is 0.3925. So this one, for this, we are, the activation function will be applied. You are getting this value. So for this is the value. And for this one, the output value is this one. Here I did not specify some value. Okay, we'll say some value. And the next one is the W5 into out H1. What is the out H1? So in this case, what are the value we are getting it here? So probably I'll just put it here. Let me open an Excel file. Yeah, it is there here, right? It's 5937625. We don't have to compute it. So this is the one. It is available here. Good. Sorry. For this one, the blue colored one, this is these two lines goes to the this neuron in the first neuron of the hidden layer. For that, the after applying the activation function, we are getting this value. And similarly for this one, right? This is called your net H1. This is out H1. This is net H2 out H2. Net H2 is your 0.3925. Out H2 is your point 0 point this value. Okay, I don't want to clutter here. So this is the one. Out H1 is this value. The next what happens is this value into 0.40 from here. For the output layer, the input is this one, out H1 into W5. The out H1 we already computed it, plus 0.40, sorry, into 0.40, plus this 0.50 into this 596, plus the bias in this layer. Even in the output layer, there is a bias. In this case, the bias weight is 0.6 into 1. This value is, let's assume it's 1.055. And if you apply the activation function, you get this one. Finally, these two are coming from out H1 and out H2. When you multiply the out H1 with the W5 weight and out H2 with the W6 weight, when you add these two things, you will get some value. And if you apply the activation function, in this case it is a sigmoid activation function, you get 0.75. This is the predicted value, 0. There is a 0.75 probability this customer is going to be a profitable customer. Okay, instead of saying defaulted, profitable. As according to us, we are very particular about the profitable customer. The probability of customer being profitable 0.756. Okay, and what is the actual value? Actual value, let's say this for a specific customer, this is going to be 1, right? So 1 minus 0.56, that is what the error. You get it. So hope you understood. This is how the computation is done behind the scene. The weights are randomly assigned. We don't have a control over here. That's why the weights and biases or parameters are called parameters, not hyperparameters, because the values for the weights and bias are computed by the model itself. So now if you see here, the actual value is 0.01, the mean squared error, right? So in this case, the error is equal to 1 by 2 into actual minus predicted value. So your actually 0.0, not 1, 0.01, and the predicted is this one. This is the error we are getting it. Okay, and so there is one input node for each attribute, and perform it to perform weighted sum, perform a weighted sum of input signals and apply an activation function before passing the output to the next layer. That is what we have seen it here. Right? It was applying the activation function here. This is the one we have seen. This one activation function. So the input layer, in the case of right here, the input layer passes the data to the first hidden layer. The hidden layer neurons perform the summation on the information passed to them from the input layer neurons. The output layer neuron performs the summation on the weighted information passed to them from the hidden layer neuron. So even here, it is doing the same thing. Okay, it is taking the value of this one. Okay, this is the one we are getting it right. 0.756. In this case, we have only one neuron is there in our output layer, so we are getting this one as an output value. Now you understood with this simple example how the computation is done behind the scene, right? The mechanics of how this one works. And next, we will take a look at the